So, statistics are mathematically based, which means they should be objective. Now, the problem is there's a lot of unintentional things that we can do that can make our statistics become inaccurate and outright misleading. Sometimes these are on accident, and then sometimes people do these things on purpose to try to skew the statistics to a result they want to achieve. So, in this section, we're going to be talking about several pitfalls and warnings that you should be aware of when you're conducting your own research or when you are reading the research of someone else. Now, let's start off with conclusions from small samples. If I am an amusement park owner and I have millions of visitors every year, I want to know what kind of new rides, what kind of attractions they would like to see. If I only interview 10 people and ask them this question, my conclusions aren't going to be very helpful because this is such a small percentage of the people that visit my park, right? Again, non-random samples are also something we should be aware of. If I'm trying to find the average household income in America, I would want to go to various places at various times, interview various people. If I just stood outside of one Walmart for 1 hour and asked everyone that walked by, I wouldn't have a random sample, right? If I was there in the middle of the workday, I probably wouldn't be interviewing people that were working, right? At the same time, people that visit Walmart primarily for shopping probably have a different income level than people that visit Dollar Tree, Dollar General, or someplace like Macy's, right? Because I'm confining myself to that one location, I'm not representing the population as a whole. Third, we have to be aware of basing conclusions off of a rare event. So, for example, if we would have analyzed the performance of the stock market in 2008 when the whole housing was crashing and everything like that, we would have had a very pessimistic view of stocks in general because this was a rare event. It didn't account for the many, many years of good growth that the stock market had. Now, poor survey methods. This is a catch-all term that encompasses a lot of different things, right? So let's say that I'm asking a survey and I don't word my question properly, something where it can be interpreted in a good way or a bad way, right? The people might not exactly understand what I'm trying to ask them, so they might give a response to the way they understand the question, which is really different than how I intended the question to sound. Another thing that we have to be aware of is assuming a causal link. So just because two things are associated, for example, I'm wearing a purple shirt today, I'm making a video today. This doesn't mean that I wear purple shirts because I make videos, and it doesn't mean that I make videos because I wear a purple shirt, right? So be careful in assuming that just because two things go together, they don't necessarily cause each other. Generalizing to individuals. Again, remember when I was giving the example of the average household income in America, right? This doesn't mean that every person makes that much money, right? So statistics describe groups, they describe populations, but they don't apply to every single individual within that group. Unconscious bias. Now, as much as we want to try to be fair and objective, we always have to understand that in the back of our heads, we will probably have some kind of bias, right? Even if this is a bias for a good thing, right? So let's say I'm working at a drug company and I think this new drug is really, really going to help a lot of people, right? Even if I'm not caring about the money, I'm still going to try to unconsciously look fully on these results. I'm going to be thinking that, oh, this drug is good, so this might influence the way I do my testing, which is why certain products have to be tested by third parties. And then lastly, we need to look at significance versus importance. And importance is itself, right? It is important for children to go to school. It is important that funding on education be used wisely, right? Significance doesn't refer to how important the underlying issue is. Significance refers to the statistics itself. So we could see that the more money spent on education, the more children learn, right? But this result, it has to be a certain level of significance, right? So it can't just be, well, we spent $100 million more and one kid did 10 points better on his final exam, right? It has to be a demonstrably proven effect, right? It has to be beyond a certain level of a doubt, something that's not simply by chance, right? So these are 8 things that you need to be aware of when you're doing statistics. I hope the video was useful, and I'll see you next time.